And here's another one. Use your calculator. As always, there's both of them on here for you to pick from, either the 83 or the 84 or the Inspire. If you're using an 83, find the function integer, which is under the math menu. Put your equation in, comma x, comma, and in this case our start and stop would be 0, comma 2, and that would be how you'd put it in on the 83. On the Inspires and the 84s, you can just happily type away with the template that it gives you. It really is quite nice using those bad boys. It gives you your approximation pretty quickly without a lot of effort. And remember that these are approximations, but they're really, really, really good ones. Okay, we've got the integral from -5 to 2 of x over the absolute value of x dx, and this is a really interesting looking shape. And again, we're going to graph this puppy. So to do that, just give yourself an x and y axis here. This actually is not too difficult of a shape to graph. Remember, we're talking about a shape that says any number divided by the absolute value of that same number. And what you're going to discover when you graph this is you get the line down here at -1, and then you get a line up here at +1. Okay? Put it on your calculator and check it out. And for you OCD kids, all those lines are parallel. Okay, now what we're going to do is we're going to talk about the area under the curve from -5 to +2. Now I'm drawing it this way for a reason. Okay, from -5 to +2. So there's two things. We want to find the area and we want to find our point of discontinuity. If you punch this into a calculator, it will give you an error message. Why? Well, because go back to what you learned in kindergarten. You learned some important things in kindergarten, and one of those things that you learn is right here, right there in the denominator. You can't have a 0. No, no, no. All right, can't divide by 0. It is not possible. Okay, so we are discontinuous at 0, which means we can't evaluate this integral. However, I do know that I have a shape of a rectangle right here and right here. And again, if you're paying attention, my graph is not perfect. But this is a 1, this is 5. This is 1, this is 2. Can I find the area of each individual rectangle, add them together, and get the area of the whole thing? Yes, I can. I can evaluate this integral by splitting it into two pieces and adding the areas of those curves. So from 1 to 5, this first rectangle is going to have an area of 5. That's this guy right here. My second rectangle is going to go from 1 times 2, and the area of that guy is 2. Okay, and so there's that rectangle right there. Now, what's going on? Don't forget some key elements. Number 1, anything below the x-axis is going to be negative. So I need to add a negative on that guy. Anything above the x-axis is going to be positive. So when I evaluate this integral, I'm going to take negative area plus the positive area and put them together. I'm going to put together -5 plus 2. And what do I get? -3. And that is this integral evaluated from -5 to 2. We just have to break it into two separate pieces. Okay, here's another one. Find the area of this integral. Solve this integral by finding areas. And also tell us where that's discontinuous. And I can't graph this one just yet. So what I'm going to do is I'm going to factor the top of this guy. So that's going to be x plus 3 times x minus 3. And I'm going to divide that by x plus 3. And then what I'm going to do is I'm going to divide out things on top and bottom. So I hate to say this because it's not technically correct, but this is what I'm looking at. I'm looking at the integral from negative 6 to 4 times x minus 3. Now, if you're a mathematician looking at this, this is not 100% correct. I have a point of discontinuity that I have to address. And if you're a calculus kid, you're just concerned with getting the right answer. Sometimes you're not concerned with too much y, but here's what's going to happen. We're going to graph the line x minus 3, which means we cross the x-axis, the y-axis at negative 3. We got a slope of 1. It's a line that looks like this. We're going from negative 6, which is over here, negative 6 to positive 4. Negative 6 to positive 4. The thing that I have to be worried about, and this is why I can't technically say that these are equal, is what happens at this point right here where these two guys are 0. I cannot have 0 divided by 0. So the other thing that I've got to talk about is at the point when x is equal to negative 3, because x plus 3, if you look at x plus 3 and set it equal to 0, when x is negative 3, I do have that point of discontinuity. And so if you try and punch this into your calculator, it will give you an undefined answer. It can't give you the answer that you're looking for, okay? So what I'm going to do is I'm going to break this guy up into two areas, okay? And I factored out the x plus 3, and that gives me this blue line. And I can now use areas, though, to find my shape. Keeping in mind, technically, I'm undefined at negative 3. Okay, and so the first shape I have is a triangle right here. Look at this. Look at this triangle right here. That's the first shape I've got. Well, how do I find the area of a triangle? Area of a triangle is 1/2 base times height. Well, my height in this case is the function at negative 6, and we're going to use this guy because he's going to be a little easier to work with. So f of negative 6, which is going to be negative 6 minus 3, which is negative 9. Okay. The other part that I need is this guy right here. I need to know what my base part is. Here's my height. Here's my height. My height is this negative 9 number. But what's my base in this case? Well, take this x minus 3 guy. X minus 3, that's what we've graphed here in blue. And we want to know where he crosses the x-axis. And where he crosses the x-axis, the y-coordinate is 0. So we're just going to solve this little baby equation real quick. And we're going to discover that this is the point 3 right here. Now that's important for the end part of this as well. So I go from negative 6 to 3. In other words, I go from here to the origin 6 units, and from the origin to here in 3 units. My whole base, in other words, is going to be 6. So for this guy right here, I've got a base of 6 plus 3, which is 9. A height of negative 9. And remember, we will get negative area in this purple shaded part because it's below the x-axis. We're not looking for total area or anything like that. We're trying to evaluate an integral. And so this is going to be negative 81 over 2. Okay, negative 81 over 2. Gosh, what are we going to do about that? Well, don't panic yet. We're not done. Then we come over here and we go, all right, I need the area under this curve right here. Well, what's my height? Again, the height is determined by the function evaluated at 4. We're going to use x minus 3 still. So that's going to be 4 minus 3, which is 1. Okay. Then we're going to use the base of this guy right here. This is my base. And the base on this particular guy goes from 3 to 4. That base is 1. So when I find the area of this pink triangle then, area of the pink triangle, okay, I'm looking at 1/2 the base times the height, which is 1/2. So how do I evaluate the integral? I take negative 81 over 2 plus 1/2. So I take negative 81 over 2 plus 1/2. And that's going to be negative 80 over 2, which would give us negative 40 as our integral. And the point that we are discontinuous at is at -3. So x cannot be -3. And that takes care of this particular problem.